Howdy. So, will this write on here? It will. Okay. So, what we have is we have somebody throwing the ball up right here. This is VI right here. And it is going to go up and it will slow down and it will stop right there. And then it will come back down. And the way you need to look at this as if they're mirror images. Whatever happens on the way up is the exact same thing that happens on the way down. So for instance, let's just make up a number. Let's say that the time on the way up is exactly 2 seconds. It's not. Then the time on the way down will be exactly 2 seconds. All right? And then the time up and down will be 4 seconds. It's not. You have to figure it out. All right? It's 7 meters. And so the way you figure out how long it takes to fall is you do 2 equals the square root of, t equals the square root of 2 times the height, which is x, divided by the acceleration. Now the acceleration the whole time, it's free fall, right? And so hopefully you know that the acceleration of a free fall is always 9.8. And so the acceleration the whole time is 9.8 meters per second squared, and that is the acceleration. How fast is it going to the peak? Well, I mean, think about it. As it gets to the very top, you could just reach right out and you can grab it very softly because it's going to come to a stop. So how fast is something going when it's stopped? So it's going to stop in midair right in front of you, okay? Because you're throwing it straight up. VF and VI are the same thing, right? So if you think about how tall it is, there's an equation that can get you. Got an alarm going off. There's an equation that can get you the that, but the best equation to use is to use VF equals AT plus VI. And in this case, you're not going to use the whole T, meaning you're not going to use this T. All right. There's ways that you could, but that's the harder way. You're going to use this T. Just find out how fast it will go if it falls, and that T will be that T. And VI will be 0 because this is where we're going to start from. We're going to start from there and fall, and this will be 0. And of course, VF is what we're looking for. And then A, of course, is 9.8 because it's in free fall. And then T is whatever you got there. So yeah, a lot of people were, a lot of people were struggling on that. So yeah, that's the idea. Okay, what else we got? I got this here. So this is just another way to look at it. I have 7 meters. It goes up slower, slower, slower. It stops. At the top, it's going 0. It speeds back down at the bottom. A is 9.8 meter per second always. The time to fall is T equals 2x over A. In this case, that's 7 meters. Time to fall is the same as time up, so the total time is 2 times whatever this time is. This is only half of it, right? This is only the way down. And the V max is A times T. And this T is not the total. This T is just the way down. And then velocity up, how fast would you have to throw it up in order to reach here? Exact same speed as it would come back down, right? So whatever VF is, that's what VI should be as well. So that should cover the whole thing. So if that doesn't work, then let me know.